Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Solahuddin bin Muhamad. My matric number is B0818100051 and I am from 4BEI, Faculty of Electrical and Electronic Engineering Technology, and my supervisor is Ts.Asri Bin Din. I am going to present my bachelor degree project, which is classification of surface degradation based on leakage current harmonics content of 6-year field edge polymer insulator using support vector machine. Okay, for project description, this project is to propose a systematic and effective methodology to estimate the surface degradation of leakage current harmonic on 6-year field edge polymer. Okay, insulators are one of the most critical components determining high voltage power network performance. Many factors affect the performance of polymer insulators in the field, including insulator design, material quality, and service circumstances. However, the polymer insulator may degrade over time owing to inevitable environmental, mechanical, and electrical stresses, and being the most prevalent causes of insulator failure. Polymer insulators play an important role in medium voltage lines. The electrical performance of polymer insulators is known to be influenced by a number of factors. Weathering, pollution, and mechanical are three elements that might diminish the insulator's performance. Several research have been conducted on the effect of weather, pollution, and mechanical on polymer insulators. However, there are no substantial studies in the literature for polymer insulator. Difficulties are caused by their age, surface roughness, and insulator degradation. Okay, the main aim of this project is to propose a systematic and effective methodology to estimate the surface degradation of leakage current harmonics on 6-year field edge polymer insulator. Specifically, the objective for this project is to process the ready data of leakage current data of a 6-year field edge insulator by using machine learning tests (MLT), and second, to analyze and to determine the consistency performance measure to indicate the class of insulator surface degradation, and last, to classify the surface degradation of polymer insulator based on leakage current harmonics content by comparing with the criteria of determination of hydrophobicity class. Okay, for research methodology, MATLAB software is a program that been used to analyze signal data by spectrogram that will be used to extract electrical parameters such as leakage current data. Okay, flowchart can help organize, stock, and lay out the needed data in data gathering. Okay, from this flowchart, first we have the ready data of leakage current. The ready data leakage current was from LVM, so we have to convert LVM file into a MATLAB file. After that, we go to process leakage current data by using spectrogram. From there, we will get leakage current of harmonic content such as total harmonic distortion, total non-harmonic distortion, and total waveform distortion. If it sufficient data, it will go to process SVM, support the vector machine. If it's not sufficient, it will go back to ready data of leakage current, and then the sufficient data will be processed through SVM to be classified, so that the data will be analyzed. From that analyzed data, we will see if the data will be differentiate or not. If the answer is yes, the data will be able to determine the consistency performance measure to indicate the class of insulator surface degradation. If the analyzed data cannot differentiate, it will be sent back to process leakage current data by using spectrogram. Okay, for result and analysis, here we got the plotted graph of mean arithmetic surface roughness and contact angle for every degrade sample. Okay, for mean arithmetic surface roughness, the surface roughness values for the control sample or CS are the smallest when compared to others with measured values between 0.422 microamp. Okay, the test sample or degrade sample, which is 3, sample 3, sample 10, 11, 19 and 20, or out of 20, on the other hand, showed the rougher surface with measurements ranging from 1.016 microamp to 1.285 microamp. The surface roughness values range between 0.568 microamp and 0.897 microamp, which is still considered a bit greater than the control samples, according to observation on the sample 2/20, 5/20, 6/20, 15/20 and 16/20. Okay, for contact angle graph, it can be seen from all the shared test samples, including the control samples, that the contact angle from these three different location is greater than 60 degree, proving its hydrophobicity properties. The other chosen samples from a variety of shades and location also show high values of contact angles, which are mostly greater than 100 degree, confirming the insulator's hydrophobicity. Okay, this is the plotted graph of percentage of classification accuracy. This plotted graph show the result of percentage of classification accuracy, percentage of CA. Machine learning will classify between two group sample, which is control sample and unlabeled sample or degraded sample, such as MLT1, which is classification between control sample and sample 1, or shared 2/20. Percentage of classification accuracy of THD for MLT1 show almost near to 50%, by reason of THD did not show much value between 60 minutes in leakage current signal. If percentage of classification accuracy almost near to 50%, then that means the sample that has been compared with control sample is a good sample. The rate of sample degradation is higher than the control sample when the percentage of classification accuracy increase to 100%. Okay, from here the table has been created to observe the similarity between the contact angle and leakage current harmonics to determine the consistency performance. As a result, we can see from the table that the EPDM polymer type insulator under mechanical test has been successfully classified into one class, which is HC1. As a result, we can conclude that the percentage of CA that has implemented a percentage THD is able to compute the hydrophobicity class and facilitating the recognition process of degraded insulators, which is required in any routine maintenance or preventative action. The consistency of the percentage CA result has been successfully classified the EPDM polymer type insulator under test into significant classes. Has C1 utilizing the percentage THD data in MLT. Okay, visual observation sample shows of the surface insulator, and generally a visual observation sample is able to show any significant variation in surfaces between three samples of insulator, but not on sample 12/20 field edge of insulator surface or control sample. And by examining the presence of degradation influenced by environmental contamination, the state of the sample 16/20 and 20/20 of 6-year field edge insulator appears to be damaged. It occurs not only as a result of the loss of smooth surface, but also as a result of the dirty state caused by the contaminated substance that has been permanently deposit on the surface. Okay, at the conclusion of this project, the project's objective has been fulfilled. The consistency of the 6-year field edge polymer insulator sample and the control sample indicate a degradation condition on the housing polymer insulator according to the findings of the investigation. The consistency of the percentage CA data had been successfully classified the EPDM polymer type insulator under test into significant classes using the percentage THD data in MLT, which are all data in hydrophobicity class 1. And the 6-year field edge housing polymer insulator showed less THD or total harmonic distortion and great hydrophobicity contact angle. So the 6-year field edge housing polymer insulator can be categorized it is still in good condition. Okay, this is how we convert the ready data LPM file into MLT file. And first, we import the ready data. Select ready data. Make sure we select all files. Open. And then we select B for variable name 2. Then we import. After that, we save as the data into a MATLAB file. And we choose converted data. Save. Okay, as you can see, this is the converted data for sample 11 for 6-year field edge and insulator of first minute. Okay, this is how we run spectrogram analysis with using the data that we have changed to MATLAB file. Okay, first and foremost, we open the LC Spectro TWD program and Spectro Enshift. First, we run the Spectro Enshift, and then we make sure that the name of file need to be changed every time the program is run. For example, we need to run the Y0611 and first minute, and then we change it to Y0611 and first minute, and then we must set the value second value second should be smaller or equal to full second. In order to set this second, we refer to this, which is for this data is 104 equal to 52 second, and then 52 second. With that, after that we click run, and it takes a few seconds to output appear. Okay, the output will come out for this program are figure 11 and figure 12. Okay, in the command windows we can get the average value for IRMS, THD, TNHD and TWD with the following type instruction. So it will continue to detect the value of n automatically. These average values will be included in the vector table for use when performing the classification process using machine learning. Okay, this is how we run the machine learning test of SVM classifier. So, first we need to extract the Excel file into MATLAB, and then we extract the label and THD data into MATLAB. After that, we run the program, and then we get 60% of classification accuracy. If the percentage of classification accuracy near to 50%, it means that the degraded samples quality near to control sample quality. If the percentage of classification accuracy near to 100%, that means the quality of degraded samples is low than control samples quality.